So for our objective today, we have this image right here where it's a clock and the hours are turtles. So our objective today, as we can see in our code, is that we're using the turtle function to replicate the image of a clock with a turtle representing the hours and a turtle at the center, with a tick mark pointing to each individual turtle. And just like the image, we want it exactly like the image, or really close. And so first off, we import turtle because we need to import turtle for our homework or for this assignment to be completed. And we set up the turtle screen. You don't really need a background color, but if you want one, you would assign a color to your WN dot background color or BG color. And we need to define turtle as anything. In this case, we define turtle as test. And like our image, we want a turtle, so we change the shape of test as a turtle. And we have test.stamp, which just shows that for our turtles to pop up as out the outer ring, those are stamps. And if we were to not have them, nothing would show up nothing will show up at the hour position. And we can check that by commenting it out. So we can comment them out and run the code. And as we can see, the turtles, which are supposed to be here where the lines extend to, are not there. And we can just check if my code is correct or not at first by uncommenting them. And when we uncomment them, we see that, oh yeah, the stamps are there. There's a turtle extending to each, or there's a line extending to each turtle from the origin where there's another turtle. And so we go back to our code and we look at our shift. We have a definition of shift which equals 360, where that's the degrees, because for most clocks, and especially the one that we're using in the image, it has the shape of a circle, and the circle is 360 degrees. And for this clock, there's 12 tick marks that represent the hours. So we divide it by 12 and we see that. And because we know that clocks and how they look, or if you were to fold it in half anyway, it's symmetrical. So we draw it just like how a regular clock would look, and we see that each hour is 30 degrees shifted. And in my for statement, I have for I in, and I have 12 different colors. You can have the range be 12 in that you have 12 ticks. I just wanted to have colors just to have more fun with it. So as you can see, I have 12 different colors, and these will represent the tick, each additional tick, and each additional turtle after it draws a new tick and turtle. They will be different colors. And we set test's color to I for this to run. Now we have t.pu, which allows test or our program to pick up the pen and not draw the trace mark from the center. And if we were to comment it out, all the pen ups, we can see that running it, the line connects. There's because we didn't pick up the pen, the line connects all the way throughout from the center turtle to the outside turtle, and that does not replicate the image that we want. So we can go back to our code and we can uncomment that and go to forward. We have forward, and you make this any length you want, but essentially you just want this one to be longer because the forward represents the tick mark, and it's really just the length of the tick mark. So if we were to comment out this forward 100, we would see that our clock is much smaller, and that there is no space between the center turtle and the tick mark. It's connected. And we can test this again by commenting out another forward and see that there's no line this time. And because there's no line and there's no forward, there's no extra space. You just have what you have. Or besides the 25, you can see right here, the forward 25. You can see it at there's no line drawn, and two, there's no additional length to the clock. And we have this pen down function that allows us to draw. So if we uncomment it, we'll notice that there will be things that will not be drawn, and we can see that it's a tick mark. So we have the stamps in the correct position, but we don't have the tick mark between the original turtle in the center and the outside turtle. And we can go back and uncomment that. And we already did stamp, I believe. We can run it again in case I just forgot for some reason. And yeah, see? The turtles are not at the stamp mark where it's supposed to be. So we can go back and we can talk about home. Home is where the turtle goes back to. It goes back to the origin or the center. And if we were to comment that out, the turtle will just progress from its most recent location when it gets shifted. And we can see this as that we can see that it'll be something really weird and it won't look like a clock at all. So we go here, we comment it out, and we run the code. And as you can see, it's going off the screen, that's one thing, but as you can see that it does not resemble a clock, and it's going in a weird pattern, or not pattern, but it's going in a weird form. And it doesn't go back to its origin after every tick like what we've been seeing. And here we have T.RT shift, which shifts the turtle in a clockwise motion, and it can be used counterclockwise if we wanted to by using LT. If you use LT, it will just be counterclockwise. It just depends on how you want your image to be projected. So we can just run it as LT and we'll see that they'll do the exact same thing, just in the opposite direction. And so let's see what happens if we just comment this out in general and what would happen. It wouldn't shift at all. It just goes to the same most spot, and you don't have a clock, you just have one tick. And it just looks like the turtles are in a line. And we set shift as an updated shift plus our new value of 360 divided by 12, because this allows us to shift it so that each tick mark is equidistant by, and that from our starting point there's an additional 30 degrees. The reason why we have to have that shift is because it wouldn't run so the way we want it to. So we can have this like move 360 degrees, and we can set shift as move plus 360 degrees divided by 12, and we'll see that it won't get what we want. Shift this. Oh, well, we didn't change this part yet. Now, let's see what happens if we were to just do this. And what would happen. It only moves once. Because it's not constantly updating. So we just undo it twice. Or how many times then we get this. So yung darkness ng garage. Or darkness ng shed. No. Admin lock. Sorry about that. I don't have any editing software. And I've done this 3 times because my parents interrupted this. So we're just going to move on. And here we have this that allows us to call the function t_clock test. And this is, we have tests because we're using tests to draw the function, or yeah, to draw the function. And we have t, which lets us use anything that we define the turtle as. Okay. And that should be everything that there was to talk about.